Welcome everyone. We're going to work on the following limits. Those are the limits involving square root. And we're going to use the method of multiplying by conjugate expression to rationalize numerator or denominator. Okay, let's get going with the first limit. So we have the square root minus 5 in the limit, and the issue with this limit is that we have x approaching -4, and in denominator we have exactly x plus 4, so that we have the problem of dividing by 0. So normally we would try to factor out x plus 4 out of numerator and cancel it, but it's really hard to do with the square root. So to enable us to simplify the numerator into something easier to factor, we're going to multiply this difference of square root and minus 5 by the conjugate expression, which is the square root plus 5. By doing so, this will enable us to simplify the numerator. To keep the fraction algebraically the same, we have to multiply by same expression in numerator and denominator. But denominator we wouldn't touch, we wouldn't simplify denominator. We're going to work on numerator only. So since we have difference multiplied by sum, in numerator we're going to have the square of the first term minus the square of the second term. That's the difference of squares formula done backwards. Okay, and if you simplify the square root squared, you end up having x squared plus 9, and then 5 squared is 25. So in numerator we have x squared plus 9 minus 25. And I'm not doing anything with denominator. So then x squared plus 9 minus 25 simplifies to x squared minus 16. And this x squared minus 16 is the same as x squared minus 4. And we're going to go ahead and factor x squared minus 4 squared into x minus 4 times x plus 4. So all of this, once we get to this stage, we get to cancel x plus 4. And we have the limit as x approaches -4 of expression x minus 4 over the square root plus 5. And now we don't have the division by 0 problem because the factor of x plus 4 is gone. So if we plug in -4, we have -4 minus 4 in numerator and 5 plus 5 in denominator. So we eventually get the answer of -4 over 5. So likewise, with the second limit, we have 4 minus square root of x. And in denominator, if you factor out x, this is x times 16 minus x. So when x approaches 16, we, in this form, have division by 0 problem. So to simplify numerator, or bring it to something better, we're going to multiply by the conjugate expression, which is 4 plus square root of x. Again, to keep things algebraically the same, we do multiplication in both places. But we're only going to simplify numerator. So in numerator, we're going to get 4 squared minus the square root of x squared. Denominator is going to stay exactly the same. And so then, simplifying numerator, we get 16 minus x. And denominator is x times 16 minus x times the 4 plus square root of x. So now we get to cancel 16 minus x, and we're looking at the limit as x approaches 16 of fraction 1 over x times 4 plus square root of x. And into this fraction we can easily plug in x equals 16 and avoid having division by 0 problem. So we end up having 1 over 16 times 4 plus 4, which is 1 over 128. We're going to work on the following two limits involving the square roots. So we're going to use the method of multiplication of... I'm going to multiply by conjugate expression so that the numerator or denominator gets rationalized and we get to cancel whatever terms we would like to eliminate. So if you look on the first limit, we have limit as h approaches 0, and we have division by 0 problem. And we have square root minus another square root in numerator. So the conjugate expression for the difference of square roots is going to be the sum of the corresponding square roots. So multiply by square root of 3 plus h plus square root of 3 in both places. And for now we're going to be simplifying the numerator. So I keep denominator as it is. In numerator we're going to have the square. Let's see. So we're going to have the square of the square root of 3 plus h minus the square of the square root of 3. So square root squared cancels out, and we have an limit as h approaches 0 of 3 plus h minus 3, and 3 and minus 3 cancels out. So we have the limit as h approaches 0 of expression h divided by h times the sum of the two square roots. This is where we get to cancel out h, and we have the limit as h approaches 0 of expression 1 over the square root of 3 plus h plus the square root of 3. And in this form, we don't have division by 0 problem. So if we plug in h equals 0, we're looking at 1 over 2 times square root of 3 as the answer to this limit. Okay, looking at the second limit, so we observe that if we plug in x equals 0, we have essentially 1 minus 1 in denominator, and that's too bad. It doesn't give us a shortcut to evaluating the limit. So we're gonna multiply top and the bottom by the square root plus 1, but this time we're gonna work on simplifying denominator, since this is what we try to make simpler. Okay, so in denominator we're gonna have the square of square root of 1 plus 5x minus the square of 1. And the square root squared gives us 1 plus 5x, 1 squared gives us 1. And numerator stays the same, I'm not even touching it. And in denominator, so we have 1 plus 5x minus 1, which cancels out once, and we have just 5x. Okay, so we're going to have limit as x approaches 0 of expression 7x times the square root of 1 plus 5x plus 1 divided by 5x. And x is a factor in numerator and denominator, so we just outright cancel it. And now we have the limit as x approaches 0 of 7 times this long parentheses divided by 5. And if we plug in x equals 0, we no longer have division by 0 issue. So plugging in x equals 0 gives us 7 times 2 divided by 5. So this ends up being 14 over 5. So that's the value of the original limit, 14 over 5.